Hello. In this video, we'll be looking at evaluating logarithms using the laws of logarithms. There are two things we're being asked to do for each question: simplify and then evaluate each of the following. For the first one, we have a sum of logarithms. So remember, a sum of logarithms can be written as the logarithm of the product by using the product law of logarithms. So this would be equivalent to log base 3 of the product of 0.5 and 162, which gives us log base 3 of 81. This would be simplified because we now have a single logarithm with a single argument. Now we're going to evaluate this. What we want to ask ourselves is 3 to what exponent produces an answer of 81? 3 raised to the exponent of 4 is equivalent to 81. So this logarithm evaluates to 4. So this would be evaluated. Evaluated means what does it equal as a numerical value? For part B, log base 5 of 250 minus log base 5 of 2. This is now a difference of two logarithms. So for this one, we would be using the quotient law of logarithms. So log base 5 of, in the numerator, 250 for the argument, and in the denominator, 2. This produces log base 5 of 125. So this is now simplified, and then we can go and evaluate it. So the question you want to ask yourself is 5 raised to what exponent produces a result of 125? 5 raised to the exponent of 3 produces 125. So this logarithm evaluates to 3. For the last one here, we're going to have to use a few of the laws, actually. We're going to start by using the power law of logs to move the 2 into the exponent of the argument. So that would be log base 4 of 4 raised to the exponent 2 minus log base 4 of 2 plus log base 4 of 8. 4 squared is 16. I'll just quickly write out the other logarithms. And then we're going to decide what should we do next. All right, so what we can do is say we have a difference of logs. So let's deal with that right now. So that would give us log base 4 of 16 over 2. And then we would still have this plus log base 4 of 8, which is equivalent to log base 4 of 8 plus log base 4 of 8. Now we would use the product law of logarithms, which tells us that the sum of two logs is equal to the logarithm of the product. So this gives us log base 4 of 64. This would be simplified. And then we would ask ourselves, 4 raised to what exponent produces an answer of 64? Well, 4 raised to the exponent of 3 produces an answer of 64. So this logarithm evaluates to 3. That would be evaluated. I want to show you a little bit of a shortcut. So suppose we didn't want to do all these extra in-between steps. From this point, as an alternative method, we could have actually applied our product and quotient laws within the same step. So continuing on from this starred step, we could have, as an alternative, said, let's put every component of, or every argument that comes from a positive log in the numerator and every argument that comes from the subtraction of a log in the denominator. So the first logarithm is positive, so we're going to put 16 in the numerator. The next one has subtraction of log base 4 of 2. So that means 2 would go in the denominator. The last logarithm has addition, plus log base 4 of 8. So that component will go in the numerator. And then from there, we would get the same simplified version that we got before. Log base 4 of 64. So it's just a little bit of a shortcut. Looking at the sign in front of the log will tell you whether that argument belongs in the numerator or the denominator. All right, thanks for sticking around for this kind of long example. Have a great day.